All right, so this is the second part of lesson number 2 on logic and propositions. We just talked about conditionals, and yeah, maybe that is a way to think about this. You know what? Let's go down to the second page, the bottom of the second page. We'll start with a review of a negation because we'll be talking about conditionals and their negations, but this is pretty much fundamental. Okay. So everything that I've talked about on first page will help you out in this exercises. So let's go to the bottom of page 2 before we go to the top of page 2. All right, so number 1, Nancy Pelosi is a Democrat. And that turns out to be a true statement. What's the negation of this? Okay, I think this is an easy one, right? Nancy Pelosi is not a Democrat. Now, you don't want to say Nancy Pelosi is a Republican, okay? Because there are people who are neither Democrats or Republicans, right? So you don't want to exclude the possibility of having somebody who is neither. So Nancy Pelosi is not a Democrat. All right. You see the pattern here? If you have a simple declarative statement, all you have to do is often insert the word not to negate sentence. Number 2, Reagan and Bush were both presidents. Ooh, that's a kind of hard one because you have this both. And so we'll come back to this one. Number 3, either raining. This word either will make this a little more complicated. Look at number 4. Number 4, tigers are not dangerous. Okay, now we have a negation already. How do you negate a already negated statement? Well, tigers are not dangerous. And you can see that the two negations will cancel each other just like two negative signs cancel each other. Negative of -5 is +5, okay? So here, you can just simply skip the word not. Tigers are dangerous, and that would be the exact opposite or the negation of this statement. All right, so this is one of those we just talked about. No babies sleep through the night. No babies, that would be a universal negation, universal quantifiers here. And so the negation of that is, again, think, how do you dispute this? How would you prove this statement wrong? If somebody comes to you and say, you know what, no babies sleep through the night, you will say, no, that's not true because, yeah, all you have to do is to provide one counterexample. So you would say here that at least one baby, or more generally, some babies do sleep through the night. Okay, get that? So anytime you see a universal quantifier, the negation would involve an existential quantifier. Everyone likes dessert. Again, a universal statement. The opposite is going to be not, nobody likes dessert, okay? Because that would exclude a situation where some people like and some people don't. So when you are going to come up with a negation of everybody likes desserts, okay, then what you want to say is some do not. Some do not like desserts. Okay. And it turns out, mathematically or logically speaking, all you have to do to prove this statement wrong is to find at least one counterexample, that is one person who doesn't like desserts, and then this statement would be false. Okay, we have 3 more problems to do, but let's go back and look at these fairly, well, a little more complicated situations. All right, the conditionals, these are hard. You may not think these are hard, but let me just show you how complicated they can be, okay? So think about an example, specific example here. P is this statement, if living in New York, let's be more precise here. If you live in New York, so the first statement is living in New York, okay? If one lives in New York, then you live in the United States. By the way, is that true? If you live in New York, you live in the United States. It is true in the real world because New York is a part of the United States, at least the last time I checked. All right, so here's the situation. The situation is you have P and you have Q, and then we have a statement, if P, then Q, the conditional statement, right? Now, because Now, bear with me in a moment. You don't have to do this anymore. I used to assign these truth tables to in homework, and I don't do that anymore because people are finding this very confusing. But I do want you to see what this truth table does, and then you will see why it could be useful when we do deductive or logical calculations. It's possible, okay, so because you have P and Q, if you have two statements and they're both independently true, they can both be independently true or false. Okay, so we have four situations or four possible cases. P and Q can both be true, or P can be true and Q can be false. Case 3 is when P is false and Q is true, and the last one is when P and Q are both false. Okay, do you see that? It's almost like flipping a coin. If you flip two coins, you have four outcomes: heads, 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 tails, tails, heads, and tails, tails. So, and in each of these, let's think about if this statement is false or not. Okay, if somebody lives in New York, so for this particular person, P is true and Q is true. So that person lives in New York, he or she also lives in the United States. No problem, right? Yeah, lots of people do live in New York, and those people live in the United States. So that's true. What about the second case? So this is a situation where this person lives in New York, and that person, oh, sorry, this is supposed to be an F. T, F. That's crazy. I can't believe that. All right, so it's TT, TF, FT, or FF. So the second situation is a problematic situation. Why? Because this person lives in New York, but he or she does not live in the United States. Well, that's impossible, okay? If this original statement is true, if you live in New York, then you live in the US. If that's true, there's no way that anybody can be living in New York and outside of the US. So this is false. Get that? All right. How about this? And this is maybe the trickiest case, number 3, false, true. If a person does not live in New York and lives in the US, is it possible for somebody to not live in New York and live in the US? Think about it. Of course it's true, right? Because there are people outside of New York that live in the US. So the fact that this third case is possible means that this statement is true. And the fourth is a person who does not live in New York, who does not live in the US. Well, that's quite possible. Anybody who lives overseas, of course, not living in New York and not living in the US. All right, all this to say, this one fact, in fact, it's so important, I'm going to write this in a different color. The only way the statement I can say if P, then Q. Remember, this is the conditional statement we are inquiring about. The only way the statement if P, then Q is false is if P is true and Q is false. Okay, this is the only one of the 4 scenarios or cases which will make this claim false. Okay, only if you can find somebody who lives in New York but does not live in the United States. Okay, what about somebody who doesn't live in New York and live in US? Well, that's okay, because the third statement can clearly be true. All right, so just keeping this in mind, it's the second case that's false. So the negation of if P, then Q is exactly this. So the, maybe it's just so, the negation of the statement if P, then Q is to say this, okay? What does that mean? P and not Q. P and not Q. So that means you live in New York and you do not live in US. See, that can't possibly be true, right? So that's the negation of the if-then statement. The negation of if-then statements does not have the word if or then. Just keep that in mind. Okay, so this is hard. This is really hard, especially given that this is only the second lesson in the course. But that's okay, you can handle it. All right, let's go ahead and try this. How can you prove this wrong? If you live in LA, and you hear this often, okay, I think this is a great example if you live in Santa Clarita or nearby. Hey, you know what? If you live in LA, then you have been to Magic Mountain, because everybody who lives in LA has gone to Magic Mountain. Right? So if you live in Los Angeles or in the Los Angeles area, you have certainly been to Magic Mountain. Okay, let's try to negate that. How would you dispute this claim? How do you prove this person wrong? You say, oh, but that's not true, because all you have to do is to find one person, at least one person, find someone who, what? Lives in LA and has not or has never been to Magic Mountain, right? You notice here, that's exactly what this is saying here. You know, the first part is true, living in LA, and the second part is false, who has not been to Magic Mountain. Therefore, the negation of this statement is the following: you live in LA, or you can say one lives in LA and have not been to Magic Mountain. That is the correct negation of the implication, or the correct negation of an if-then statement. All right. Ooh, that's hard, huh? Okay, so let's draw a diagram about if and the or statement. So this is, remember, this is called a conjunction. This is called a disjunction. Now we are going to think of the opposite, or the negation of a conjunction statement and the negation of a disjoint or disjunctive statement. All right, so here's a person, or here's a claim: I am both a singer and an athlete. Okay, so what we do is we draw these circles. We call these Venn diagrams. But let's say we have a circle of all the singers. Okay, now we also have a circle of all the athletes. And then there's a universal set that contains everybody. Notice here, because we have two classes of people, singers and athletes, this will classify all the people into 4 categories, okay? You see that? We have here the people who are singers, but not athletes, right? And then right here in the middle, we have people who are singers and athletes. And then we have athletes who are not singers. And then there are people out here that are not singers or nor athletes, right? And so there are several people here. Now, when we say singer and an athlete, this is the statement: I am both a singer and an athlete. That would put this person right in the middle, in what we call the intersection of the 2 sets. You see that? Okay, so the claim, I am both a singer and an athlete, will put the person who claims this into this middle category. What is a negation? Well, negation should be everyone who is not in the middle. So all of these people. Okay, how do you get to one of these categories? Well, okay, there are a couple of ways to do this. All you have to do is to avoid being both a singer and an athlete. You can be a singer as long as you're not an athlete. You can be an athlete as long as you're not a singer. Okay, so the answer to this is this, and hopefully you can appreciate this. The opposite of this is not, the negation is not a singer. Okay, you can say either not a singer or not an athlete. You get that? Okay, I forgot to mention this. You know what? Maybe I should. Let's go back to the first page. All right, because the negation of the proposition is often written as something like P. Okay, the negation is often written with this wavy line P, and this means the negation of P. Okay, these are symbols we use in mathematics. So the negation is written as with a wavy line in front of the proposition. And so here is the idea, okay? What we are saying here is that the negation of S and A, the negation of both singer and an athlete, is equal to, what did I say? Either not a singer or not an athlete. Okay, so again, let's go back and see what it says. The negation of singer and an athlete is either not a singer or not an athlete. Okay, so the negation of an and statement turns out to be an or statement. Okay, tricky, yes. Let's look at the second category, second case. The disjoint statement, he is either a singer or an athlete. Think of somebody, yeah, I'm not really sure what he does, but he's either a singer or an athlete. We have the four categories of the people again, but this time, all we are saying is he's one of those people. He's either a singer, or he's an athlete, and perhaps he's both. In both, that's okay to say he's either a singer or an athlete. So this claim would put this person in a pretty large area of this Venn diagram, either a singer or an athlete or both, okay? So who is excluded from this? Well, that's all of these people out here. And that's what, okay? If you're a singer, you happen to be not in the green region. If you're an athlete, you are not in the green region. So the only way to avoid being in the red region here is you have to be both non-singer and a non-athlete. Okay, you get that? So the negation is both not a singer and not an athlete. Complicated, okay? So here's the notation. And I know these symbols could be very difficult to interpret, especially if you are not familiar with, you know, like logic and mathematical notation, but I hope you understand this. Again, the wavy sign means the negation. What we are saying here is the negation of being a singer or an athlete is both not a singer, you have to be a non-singer first, and you have to be a non-athlete. Okay, so what you're seeing here is the negation of an or statement is actually an and statement. Okay, so yeah, these are pretty challenging concepts. All right, we call these two things laws De Morgan's laws. Because the first person to make this specific and clear is a mathematician, a logician, a philosopher of the UK named Augustus De Morgan, who had a very interesting life, and there have been books written about De Morgan. And so anyway, De Morgan's laws will say the negation of P and Q is the negation of P or the negation of Q. The second law says the negation of P or Q is the negation of P and the negation of Q. Okay, I know it's, again, complicated, but let's try to logically understand it, perhaps using some specific examples that would maybe help you out. Okay, so let's go to the rest of this and we'll finish this lesson, and then you can work on your worksheet number 2. All right, so the second one says Reagan and Bush were both presidents. That would be this type of a situation. Both Reagan is a president and Bush was a president. So how would you make this claim? How would you argue with this claim? How would you dispute this claim? All you have to do is to show that one of them wasn't, right? So either Reagan was not a president, or Bush was not a president. I know it's wordy. Maybe there's a more concise way of writing this, but I hope you get the idea here, right? So the claim is both Reagan was a president and Bush was a president. And the negation of that would be either Reagan was not a president or Bush was not a president. Okay, you don't have to prove that both were non-presidents. All you have to do is to show that at least one of them was not a president. Okay, number 3 says either it's raining or very cloudy now. Either it's raining or very cloudy now. So that's an and, that's an or statement. Either this or that. And to negate that, you would have to come up with an and statement in which both are, negated. So either it's raining or very cold now. So what's the negation? It's not raining. And remember, the and is in the middle here. Okay, it's not raining and it's not very cloudy. Okay, so that would be the correct negation. We started with a simple negation, and notice here things got very quickly became rather difficult. So I hope you actually understand. Oh, one more thing here: understand these things, and how to negate a statement. It really is an important concept in the mathematical world. All right, finally, I don't know. Do you guys know who this guy is? Chicharito. He's a soccer player from Mexico who is playing for the LA Galaxy. If Chicharito scores, the Galaxy will win. Okay, so that's a claim. Now, how would you dispute this claim? You say, oh, that's not true. Okay, the negation of this will be, let's go back in here. This will be the first point we covered on page 2. If you live in New York, then you live in the US. The negation is you live in New York, but you don't live in the US. So it'll be P and not Q. I think it makes sense because if somebody makes a claim like this, if he scores, the Galaxy will win. I say, no, 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 no. The only way to claim or to prove this statement false is, now remember the word if and then do not occur here. The negation is Chicharito scores. And how do you make this claim false? He scores and the Galaxy will not win. Okay, it makes sense, right? I mean, if somebody says if Chicharito scores, the Galaxy will win, and say no, 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 I will prove you wrong. And the only way you can prove him wrong is if he scores and the Galaxy does not win. If he doesn't score and the Galaxy does not win, then that's okay. I mean, this guy didn't claim anything about what happens if Chicharito does not score. If he scores and the Galaxy wins, that's okay too, right? The only way to claim him wrong is if Chicharito scores and the Galaxy does not win. Okay, so you may have to look at some parts of this maybe a couple more times before you can clearly understand how to negate statements. You can also read the textbook and the appropriate section before you do your worksheet number 2, or you can go back and look at this video again. All right, so until next time, I will see you.